So let's go ahead and go a little bit more in depth into some of these subjects, moving on to the second part of this webinar here, where we'll discuss management of the wheat crop as well as livestock when the wheat is grown for dual purpose. So wheat, whenever it's grown for dual purpose, it requires a different management practice than that wheat grown for grain only. And the first management practice that I would like to discuss here are planting date and seeding rate. So this graph, it shows wheat fall forage yield as affected by seeding date and by planting date as well. Seeding rate and planting date, sorry. Data was collected from north central Oklahoma, so it's probably representative of that area, south central Kansas, north central Oklahoma, from 1991 to 1994 here. And what is clear from this chart is that fall forage production is much greater at earlier planting dates, as shown by the black data as well as by the red circle. So the black squares, they are 28th of August planting date, and the red circles are 11th of September. These graphs also showing us that the wheat sown after September 25th in this region have very little potential for fall forage production in most years. And this data is summarized in green and blue here, so very, very reduced forage production. What else is this graph showing us? So these curves are also showing us that increasing seeding rate to about 120 pounds per acre increased forage production regardless of the planting date, and also that switching from about 90 to 120 pounds of seed per acre generally justified the additional cost of the seed because of the amount of biomass, extra biomass that was produced. So to maximize wheat fall forage production for that central region, here's that seeding at about 120 pounds per acre should be adequate for this central region of the southern Great Plains. And the earlier the planting date, the more forage will be produced. So it's interesting to notice that delaying planting date in 2 weeks here, as you can see by the purple arrow, from September 11th to September 25th, decreased fall forage production about 1,000 pounds per acre. So it's a steep decrease as you're delaying planting date here in this region. So to maximize forage production, it is necessary to plant early. Now, as we're talking dual purpose systems, there is a trade-off because the earlier you plant, the lowest the grain yields tend to be. So producers really need to find a balance between the best day to maximize forage production and to minimize grain yield losses due to early planting. Now, for this region, seems that about September 15th is a good goal to have that wheat planted, and for other regions in the Great Plains, I guess about 3 weeks to a month before that best planting date for grain only seems to give an adequate planting date for dual purpose production. Now, another management practice that we need to keep an eye on is really planting depth. So as wheat is planted early, it's often going to be planted into drier and hotter soils. It's not uncommon actually to sow wheat into 100 degrees Fahrenheit soil temperatures. So whenever we're in this scenario, we have 3 things to be considered here. 1, seed dormancy, as we're planting earlier than optimal. 2, high temperature germination sensitivity. And 3, a decreased coleoptile length, as we're planting into hotter soils. So really, when you talk about seed dormancy, it occurs naturally in most wheat varieties. So this condition is just a condition in which the seed will not germinate, even under favorable moisture and temperature conditions. So overall, seed dormancy is a very good thing. It helps prevent pre-harvest sprouting, as you can see here in this picture to the right. The highest level of seed dormancy generally occurs just before harvest, and it's gradually lost with time. So that by October, generally the post-harvest dormancy should have dissipated in most wheat varieties. Now, when sowing early for dual-purpose production, say early September in some regions, there will be less time between harvest maturity and sowing, so that seed dormancy may not have completely dissipated by then. So this really is one issue that we need to be aware of when planting wheat early. second factor that I mentioned would be that we need to take into account as well is high temperature germination sensitivity. This, in other words, means that some varieties will not germinate under hot soil conditions. And this event really differs from the true seed dormancy because a cool rainfall event, for example, it may overcome and may lead to germination, for example. So it differs from true seed dormancy, but it's an event where some varieties will not germinate with hot soils. So high temperature germination sensitivity is variety specific, and there is great variability between varieties, as you can see here in this chart. Varieties that are more sensitive to hot soil conditions, such as Overly, 2174, or even Centerfield, should not be sown early with the risk of decreasing germination and stem establishment as well. Finally, the third factor we need to consider when planting early is decreased coleoptile length. So what is coleoptile? The coleoptile is a rigid protecting structure that covers the emerging shoots, as you can see here in this representation to the left. So what happens once the coleoptile reaches the soil surface, it stops growing and the first true leaves emerge. So, and this is represented here in the pictures to the right. So the problem with early planting is that hot soils often decrease the coleoptile length. And in case the coleoptile does not reach the soil surface, the first true leaf emerges below the ground and the wheat plant typically dies. And here we have a picture that is a clear example of that. So the wheat plant on the top of the picture has kind of this accordion-like leaf, which is a typical symptom of when the coleoptile did not reach soil surface and that leaf came out still below the surface, the first true leaf. Now, if you check the wheat plant below, you will see an elongated coleoptile, but that reached soil surface and allowed the first true leaf to be exposed. So really the main problem with these is that our modern semi-dwarf wheat varieties, they already have a shorter coleoptile length than some of the old tall varieties. So it already increases the likelihood of that coleoptile not reaching the soil surface in hot soil conditions. Varieties differ in their coleoptile length, as you can see here on the left, another publication put by Oklahoma State on this issue. And so one of the options is to try to avoid some of those very short coleoptile varieties. So really going back to planting depth, one of the considerations here is to never plant deeper than the coleoptile length, especially when planting early because we're planting into hot soils. And second, that there hasn't been really, if there hasn't been a considerable precipitation event in the last few days, and there's no moisture within that first inch to inch and a half of the profile, it's usually better to plant shallower and wait for rain, or in other words, dust the wheat in, than to plant deeper, because the chances are that the decreased coleoptile length will not allow for the coleoptile to reach the soil surface if planted deeper. Some of the other consequences of an early planting wheat, typical on these dual-purpose systems, is increased incidence of fall insect problems. So I'm not going to go into much detail into these, but I'll just show some of the possible insect-related problems that can be a consequence of early sowing of wheat. One example here is a hash and fly that can really decrease with yields, increase with lodging. So with early sowing, it increases the risk of hash and fly problems, so that there is what we call the hash and fly free date, which generally was the date of the first freeze event, right? As we're in dual-purpose systems, we're generally planting before that date. So we need to take that into consideration. And as far as control, the genetic resistance is generally the best defense that we have here, as seed treatments generally do not provide season-long protection. Also, aphid-related problems are more likely to arise when we're planting wheat early. Aphids transmit the barley yellow dwarf virus, and those fall infestations of barley yellow dwarf can be really devastating to the wheat yields. So if critical levels of aphid are measured, it might be a good idea to chemically control as long as insecticide treatments may only prevent infestation the first 15-30 days, so are not too efficient if aphids continue to appear after that period. And the last insect problem that I'm going to touch on today here is wheat curl mite, that can transmit wheat streak mosaic. So the wheat curl mite generally requires what we call green breach to infect the wheat. So this green breach, it can be wheat, volunteer wheat, it can be corn or grain sorghum, or even other species. And it is recommended that this green breach must be eliminated if the plant is actually dead at least 2 weeks prior to planting the wheat crop. So this can be really more challenging when we're planting wheat early in dual-purpose systems. So some of the other considerations that we need to take when growing wheat for dual-purpose are related to soil fertility and nutrient management. So today I'm going to discuss the role of soil pH, phosphorus, and nitrogen management, and how these are affecting forage production, and also how to manage these whenever we're growing wheat for both forage and grain. So I'm going to start with soil pH for two main reasons. First, low soil pH have been increasing, so it's an increasing concern in the majority of the area where wheat is grazed, including central Oklahoma, south central Kansas as well. And the reason for low soil pH in these regions is really related to continuous wheat production and nitrogen fertilization, which contributes to that low topsoil pH. The second reason is because soil pH will really impact the availability of all the other nutrients that you can see here in this chart. So the availability is especially impaired at low soil pH. Generally, soil pH levels below 5.5 to 6. And also, there is an exponential increase in aluminum availability when the soil pH decreases below about 5.5, as you can see here in this graph. So this increase in aluminum availability will have a few consequences, right? Especially it's going to decrease the wheat root growth. So with less root, the wheat crop will be able to explore less the soil for both water and nutrients, and really is going to decrease the top growth as well. So the decrease in root growth combined with that decrease in phosphorus availability, it's really going to impair wheat development, as you can see here in this picture. So much less root development, much less tillering, much less forage production whenever growing wheat in low pH soils. In fact, I studied while I was still at OSU together with Brian Arnau and Jeff Edwards, where we're looking at the effects of a soil pH gradient in wheat forage and grain yield. And in this study, we were evaluating 4 different wheat varieties grown in soil pH gradient ranging from about 4 to 8 in a dual-purpose situation. And there was really a very sharp decrease in wheat fall forage yield, as you can see here in these charts, whenever soil pH levels fell below about 5.5 to 6, really depending on which variety we were growing. So to be on the safe side, what we can recommend is that soil pH must be maintained above about 6 to maximize wheat forage production in these dual-purpose systems. So this graph shows you how the study, you can really see the sharp decrease as the pH went below 5.5 to 6. Now, how did this look in the field? You can see here on this photo, and you can see that here on these 4 plots, we had the target pH of 4, wheat forage production was really, really decreased. The next 4 plots had the target pH of 4.5, and wheat forage production was still low, and so on and so forth. As far as wheat grain yield, following grazing termination here, and this was a simulated grazing, but wheat grain yields, they were not. There wasn't really such a clear relationship as we saw with forage. You can see here on these graphs, the critical soil pH to maximize grain yields, it ranged in between 4.8 to 5.8, depending on variety sensitivity as well. So this really showing us that grain yields were a little less sensitive than wheat forage yields to acid soils. So really some conclusions about managing soil pH for dual-purpose reproduction. Forage is more sensitive than grain yield to low soil pH, so we do need to aim and try to keep the pH above about 6. So we're maximizing both forage and grain yields. So to keep this pH at these levels, it is recommended to soil sample at least, say, about 2 years, and assess the current soil pH conditions, apply agricultural lime according to the university recommendations. Now, in cases when the investment in lime is not doable, say, this year, blending P fertilizer in furrow can be an option to try to alleviate some of this low pH and increase wheat forage production as well. So this really leads us to the second topic within soil fertility here, which is soil phosphorus management. So generally when I talk about dual-purpose wheat production and soil phosphorus, I like to quote something that I heard from Brian Arnall once, which goes more or less like, in furrow phosphorus is money in the bank. And in fact, providing those seedlings with that banded phosphorus is much more, makes phosphorus much more available, especially in low pH soils, that can really improve wheat emergence, early season root growth, and tillering, and consequently forage yield as well. And generally, adding about 50 to 60 pounds per acre of diammonium phosphate or equivalent from other sources should get the job done. So this graph here really shows us the effect of different lime strategies on wheat percent green canopy cover on a low pH soil. So this soil had a pH of about 4.7. You can see that, well, percent green cover, as we commented before, it's a largely function of the amount of tillering, and it's highly correlated with forage yield. So here you can see that 50 pounds per acre of banded DAP, diammonium phosphate, resulted in the greatest green canopy cover, even greater than lime in this case. So that's the green line as compared to the blue line here. So also showing that banding P may be an alternative when, for example, leasing ground to avoid that long-term, we can call it commitment of lime, right, and that long-term investment of lime. Finally, some thoughts here on nitrogen fertility for dual-purpose wheat production. Bottom line here is that dual-purpose wheat will require more nitrogen than grain-only wheat, especially during the fall. So a good rule of thumb is that about 30 pounds of nitrogen per acre are required for each 1,000 pounds of forage per acre to be produced, or for each 100 pounds of beef per acre to be produced. Those are current recommendations, right? So, and then additionally, we need the supplemental nitrogen applied prior to jointing to complement grain yields. We do have, well, currently Dorivar, who is Diaz here at K-State, he's got a project looking into fine-tuning some of these nitrogen recommendations whenever wheat's grown dual purpose, which is also part of the grazing cap project. So he's including some sensor readings among other technologies to try to fine-tune the nitrogen recommendation for dual purpose production. So as far as the grazing management itself, we'll discuss a little bit about grazing initiation, grazing termination, and some thoughts on livestock management as well. So as far as grazing initiation, grazing should not be initiated before a good development of the secondary root system. So as you can see in these pictures, developing wheat plant has both seminal roots and crown, or what we call secondary roots. The secondary roots are the ones that will actually be responsible for absorbing most of the water and nutrients for the plant throughout its life cycle. But it's especially important in dual-purpose system because they're going to anchor the wheat plant to the soil. So they're going to avoid that whole plant removal by the cattle. Both of the plants in this picture are actually way too young to be grazed. Neither of them has a good secondary root system developed yet. We generally think of a minimum of about 6 to maybe 8 inches of top growth needed before grazing initiation. But it is really important to remember that good top growth will not necessarily indicate a good root anchorage. So really the best way to determine if plants are anchored enough is to really pull a few of those whole plants out of the ground and evaluate the root development. So as you can see here in these pictures, we have one example on the left in which we would still like to see some more root development prior to initiate grazing on this crop, while the plants on the right should already be well anchored. You can see by the amount of secondary roots. So these would most likely not be removed by cattle. So some considerations now on the livestock management side of grazing wheat pastures. Well, both stocker cattle and mature animals can graze wheat pastures, but due to the high quality of the forage, there's generally greater profitability if we're grazing it with stockers or fall calving cows. So optimum stocking rates will depend again on the environmental conditions that we had for fall forage production, as well as on wheat management. But on average, some previous case state data shows that wheat pastures will allow for a stocking rate of about 1 to 2 acres per stocker during fall and winter, and about 0.75 to 1.3 acres per stocker during the spring. So these stocking rates can possibly be increased by providing dry feed, again, because of the high quality of wheat pastures, so providing, say, grass hay or silage or some limited grain. And some data here from K-State also supports daily gains ranging between 1.5 to about 2 pounds. So grazing termination, that's a very important point that we need to remove cattle, otherwise we're going to start hurting our wheat yields. So in order to minimize the yield losses that are associated with grazing, it is really important that cattle is removed by first hollow stem. So in the past, cattle was generally removed at a fixed date, say March 15th, or in some cases when wheat was jointed. But there's some research that has demonstrated that jointing is already late. So the yields are already being reduced if we're only removing cattle then. So what is first hollow stem? First hollow stem, as you can see here in these pictures, it occurs when there's about 1.5 centimeters, or say about half an inch, of hollow stem present below the developing wheat head. As you can see here in this picture, the plant to the left is already at jointing, so it is past first hollow stem, while the plant in the right is about 1.5 centimeters of hollow stem below the developing wheat head. Luckily, 1.5 centimeters is equivalent to the diameter of a dime, so this really makes life easier. So how do we check for first hollow stem when out in the field, right? It's very important to check from ungrazed areas of the field. Again, because grazing will delay the appearance of the first hollow stem. It's going to delay crop maturity, as we have previously talked about. And these ungrazed areas may be found either on field corners or just outside the electric fence that have not been grazed. Very important to be from the same field with the same variety, but needs to be ungrazed. And we generally check for the first hollow stem by digging 4 or 5 plants from these ungrazed areas, splitting the largest tiller lengthwise, starting at the base, and measuring how much hollow stem is present below that developing wheat head. And here's a couple more pictures from Jeff on this specific stage. So this happens towards the end of fixed growth stage 5, just prior to jointing. You can see really clearly about 1.5 centimeters of first hollow stem here. So grazing past first hollow stem, it's going to result in yield reductions. These yield reductions, they can yield anywhere from about 1% to over 5% per day, really depending on conditions for regrowth. So if at grazing termination those conditions are cool and wet, they will be more favorable for wheat recovery. So grazing past first hollow stem under these cool and wet conditions will have less effect on grain yields. So generally we're looking at maybe 1% per day there yield reduction. Now, if we're grazing past first hollow stem in dry and hot and some harsh conditions, that will really accentuate the yield losses. So These yield losses can be up to 5% or more per day. Right? So that's why checking for first hollow stem is very important. So we're making sure that we're sustaining our wheat yields. So the question is, do I need to be out checking for first hollow stem for a full month from late January now up to early March? Well, maybe, but maybe in the past. Now we do have a tool that was developed by the Oklahoma Mesonet that can help producers narrow down that window that they need to be out checking for first hollow stem. So here you can see the first hollow stem advisor, which can be accessed from the agriculture section of the Mesonet website. And this product, what it produces is actually a prediction of the probability of first hollow stem. So within the next 2 weeks, right? So what's the probability that my crop is going to achieve first hollow stem in the next 2 weeks? As you can see in the chart here, 5%, 50%, 95% probability. So we really know that, well, we should be out checking and really thinking about removing the cattle. And these predictions really done based on current weather during the growing season, historical weather averages for that location for the next 2 weeks, and also depending on which wheat variety that is being grown. So generally they are grouped into early, medium, or late first hollow stem varieties. As part of the grazing cap as well, the model developed by Oklahoma Mesonet, we're currently validating it for Kansas conditions. So we're looking at first hollow stem South Central Kansas. So if that model really predicts the behavior of the different varieties well here up north, this may be a possible collaborative product for Kansas producers in the near future as well.